Hello, I'm Jeff, and today we are going to be tackling one-sided limits. We're going to be learning how to solve, how to understand, and how to apply them within the context of a function. So without further ado, let's just get right into it. So we have a piecewise function that's divided into two parts, defined as f of t. And we can see that the function f of t models the velocity of a vehicle as it travels down a road. Okay, that doesn't seem too bad. So looks like over the interval from 0 to 15, we have a car that just starts at 10 miles per hour, let's say, and it's gradually increasing in velocity until we have this sudden jump. And this is what's called a jump discontinuity because we have this sudden shift in the graph's position. It's just jumping down here without any sort of actual connection. So, what does that mean? Well, what we can imagine might have happened here is maybe we were driving along the road and suddenly we were driving in fog and we encountered a large batch of snow or ice. And that abruptly slowed our car down and suddenly we started braking. So the function then shifted downwards in this negative direction that would correspond with braking. So that makes a good deal of sense. Now, what if we were to try to solve the limit of this function as t approaches 15 seconds? And we can just say seconds or any arbitrary unit here. I think seconds makes the most sense considering the time frame on which this is happening, but it doesn't really matter. Just more for a conceptual understanding. Well, you can probably remember that the definition of a limit is approaching a certain value from both directions, which is clearly not happening here. Over here, we have it from the right side approaching the value of 20, and over here from the left side, we appear to be approaching a value of about 25. So these clearly aren't equal, so we'd say that the limit of this function does not exist. So that's it. That's the end of the story, right? Well, in comes the one-sided limit. Calculus, my dearest. Always an extra annoying step to bless us with, huh? Alright, well, since the limit of f of t as t approaches 15 doesn't actually exist, let's go ahead and try our illustrious one-sided limits. So, the difference between a normal, regular old limit, also known as a two-sided limit, and a one-sided limit is, as the name might imply, a one-sided limit only has to approach from one single direction. So, this limit would be the limit of f of t as t approaches from the positive or the rightward direction. So that means that we'd follow this function on this direction, and that would reach about 20, it appears. And then evaluating from the leftward direction, we can see that looks like we're going to approach 25. And just to confirm that, we can go ahead and try it algebraically. So for the left side, that would be the interval from 0 to 15. We can simply plug 15 in, and that gives us 15 plus 10, which is 25. And then from the other direction, from the interval of 15 onwards, we can go ahead and plug 15 in once again. And that just gives us 20 minus 15 squared is equal to, well, this all just cancels out to 0. It gives us 20. Beautiful. That looks like all right, perfect. We have our answers. So that means that when f of t approaches 15 from the right, that'd be from this direction, we can say it's equal to 20. And then when f of t approaches 15 from the leftward direction, which is this direction, we can go ahead and say that it's equal to 25. Voila, this question is solved. So now that we understand what a one-sided limit is and how to use it, let's go ahead and tackle some more problems. All right, so we have another problem. F of x is equal to, look at that, another piecewise function. Sensing a theme? So solve the following questions. So before I walk you through all of these, I recommend you go ahead and give these a try and pause really quick. So assuming you didn't just sit on your butt and do nothing, let's get right into it. So to start off with, we have the value of f of 4 for question A. Okay, well, that seems pretty simple. All we have to do is look at the bounds that are defined here, and we can see that, oh, when x is equal to 4, we just get 3. So that would mean that f of 4 is equal to 3, no problem. And we can see, just by observing this, that we actually have not only a jump discontinuity, but a removal discontinuity as well. F of 4 is just completely divorced from the entire rest of the function. Seems a little tragic, to be honest. Maybe it resonates in a certain way. All right, well, anyway, moving on to the limits. So we have the limit of f of x as x approaches 4. Well, we've played this game before. So looking at this, we can see that, well, these clearly aren't equal. We're not approaching the same value at x is equal to 4. And we can even solve this algebraically, just to confirm. So if we plug 4 into the first part of this function, we get 1 over 4 times 4 squared, which is 16, minus 4 minus 2. And this will go ahead and simplify to, well, we have 16 divided by 4. That gives 4 minus 4, which is just equal to 0, and then minus 2, which gives us, as you might expect, negative 2. All right, and then for the second part of this function, well, this one's a lot easier. We just plug 4 into this, and that gives us 8 minus 8, which is equal to 0. And, well, last time I checked, negative 2 is not equal to 0, which means we would say that this limit does not exist. D and E, once again. All right, and then for the limit as x approaches 4 from the negative direction. So in this case, well, we've actually already solved for this. So we know that from the leftward direction, it's going to approach negative 2. No problem. So we can just go ahead and put that there and move on. And then as the f of x approaches 4 from the positive direction. So as we approach from the rightward direction, that's going to give us, well, we've solved for this one as well. That's just going to give us 0. So there we go. No problem. See, once we understand the concepts of a one-sided limit, it's actually pretty simple. So with that, let's move on to the next. Okay, we have our next two questions here. So, question one, if the limit of f of x as x approaches 5 is equal to 2, what are the limits as it approaches from the left and the right direction? Okay, well, this is a little interesting because we're not provided a graph and we're not even provided the actual function of f of x, which seemingly makes this a little bit more difficult to figure out. But all this is a test of our understanding of limits. Because if this limit exists and it equals a specific number, as it does here, well, that means that we're approaching that number from both directions. Otherwise, it wouldn't exist. So that means that we're approaching 2 from the left and we're approaching 2 from the right, which means, well, these are just going to both equal 2. Voila, no problem. All right, so next question. What are the one-sided limits of f of t as t approaches 1? Okay, so this time we're provided f of t, but we don't have any sort of graph. That's no problem. So looking at this really quickly, we can see that this function is going to be continuous for all real numbers, and that's because it's a polynomial. And there are no jump discontinuities because this isn't a piecewise function. There's no division by 0, so we don't really have to worry about anything here. So we can just find the regular limit and say that that is going to be equal to the limit from both sides. That's no problem. So let's go ahead and just substitute 1 on in. So that gives us 1 to the third power minus 3 plus 4. And then 1 to the third power, that's just going to be 1. So minus 3 plus 4, and that gets us 2. No problem. So that means the answer to this from both sides is just going to be 2. Excellent. That means that we've solved all the problems for today. You see, that wasn't too bad now, was it? All right. Thank you sincerely for watching. If you enjoyed, please remember to like, comment, and subscribe. I appreciate it all. And I hope to see you next time. Have a wonderful day.